an absolute value function, what it does is it makes the value inside the absolute value a positive. So that's what the function does, is it takes whatever's inside and makes it positive. So -3 becomes +3. If it was +8, it stays +8. If it was -x, it becomes +x. So let's look at an absolute value equation. If we have this equation, the absolute value of x equals 5, what that means is x could equal 5 or -5. Because if we take the absolute value of 5, if it's already positive, it's just going to equal 5. And we can take the absolute value of -5, and that's also going to equal 5. So the possible solutions, if we get an absolute value that looks like this, is that whatever's on the inside could be either positive or negative. And this holds true if there's an expression inside the absolute value. So if we have this expression, if we have this equation, the absolute value of y minus 3 is equal to 2, then what's inside is the expression. And that means that this y minus 3, if we change it to brackets, is going to be either plus or minus. So the positive version, y minus 3 equals 2, or we could have the negative, y minus 3 equals 2. So the plus or the minus would work. And this is the basis behind solving absolute value equations. We can get a positive and a negative term for the expression inside. So let's look at solving an absolute value equation. We have this, the absolute value of 2x minus 3 equals 5. What that tells us is that we could take the positive version, and all you're going to do is you're just going to take the absolute value, change it to brackets, and one is just going to be 2x minus 3 could equal 5. The other equation is just going to be the negative of that. So we're just going to say the negative, take whatever the expression is, 2x minus 3 has to equal 5. And really what we have to do now is we have to solve two equations to figure out this absolute value. So we're going to get 2x minus 3 equals 5, so 2x is going to equal 8, so x is going to equal 4. So that's one possible solution, x equals 4. And now to solve the second one, we just distribute that negative in. Negative 2x plus 3 equals 5, so negative 2x equals 2, so x equals -1. Now, we always have to check to make sure that our solutions are correct. So we always have to check to see that we have the right solution. So let's check x equals 4. So all you do is you just take 4 and you put it back into the original absolute value equation and see if it solves the original equation. So, absolute value of 8 minus 3. Is that equal to 5? Well, of course, the absolute value of 5 is equal to 5. So we know that x equals 4 is the solution. So let's check x equals -1. So the absolute value of 2 times -1 minus 3, does that equal 5? Well, this becomes the absolute value of -2 minus 3. Does that equal 5? Well, of course, the absolute value of -5 equals 5, so that's true. So we can say that our solution is both x equals 4 and x equals -1. So those are both the solutions to this absolute value equation. So there's no extraneous roots in this case.